Hello and welcome back to part 2 of our lesson on energy. This is still on Gomat Online Academy, and in this class we are going to discuss how to calculate the energy of a body and how to also get the relationship between energy, work and power. In the previous class we talked about the definition of energy. We also talked about the units of energy, the types of energy, that is potential energy and kinetic energy. And we also talked about the forms of energy, sound energy, light energy, and others. And then the formulas for calculating the energy of a body. We said that we have two formulas, the formula for calculating potential energy and another formula for calculating kinetic energy. And also in other classes, we've talked about work and we've also talked about power. Now in this lesson, we are going to show the relationship that exists between energy, work and power. So let's start. Like we said in the other class, that we have two types of formulas for calculating energy. One is formula for potential energy. For potential energy, which we can denote with PE, we use the formula mgh, where m is the mass of the objects, g is acceleration due to gravity, which is always given as 10. If the value 10 is given to us, fine, but if it is not given to us, we use 10 to do our calculation, while h is the height where the object is located. Now we have another formula for calculating kinetic energy. For kinetic energy, which we can denote with Ke, it is denoted with Ke. The formula is half mv squared. Half mv squared, where m is the mass of the object and v is the velocity of the object. Velocity is the same thing as the speed of the object. So if they call it velocity, fine. If they say that it is speed, you know that they are talking about the same thing. Now remember that kinetic energy is the energy that is possessed by a body that is performing work or a body that is moving. So the formula includes velocity or speed, because if an object is moving, it will be moving at a certain speed. So that is why we have velocity in the formula for kinetic energy. Now let's look at some examples. Example 1. Example 1. Calculate the energy. Calculate the energy of a body. Calculate the energy of a body of mass 20 gram if it is moving with a speed of 10 meter per second. Now solution. Now for us to calculate this, we have to bring out the parameters given to us in the question. The parameters given to us are: number 1, mass of the object, which is 20 gram, and number 2, the speed of the object, which is 10 meter per second. So mass is equal to 20 gram and velocity or speed is equal to 10 meter per second. Now our formula for energy: this body is moving. That means that it possesses kinetic energy. And the formula for kinetic energy says that the body is moving with a speed of this, so it possesses kinetic energy because it is moving. Now we use the formula for kinetic energy. Kinetic energy, Ke, is equal to half mv squared. Now we know our mass as 20 gram and we know our velocity as 10 meter per second. Now we put everything together. We have that Ke is equal to half times 20, half times 20, half times 20 times velocity is 10. 2 go 10. So we have, this is 10 raised to power 2. That is v squared. So we now have 10 times 10 raised to power 2. Therefore, our potential energy, our kinetic energy now is equal to, the kinetic energy Ke is now equal to 10 times 10 raised to power 2 is equal to 10 times 100, which is equal to 1000. And the unit of energy is joules. So we have 1000 joules. Now, like I said in the previous class, that we can convert joule to kilojoule. 1000 joule is equal to 1 kilojoule. So if this is an obj, instead of writing 1000 joule, you may not see this in the option. They may just give you 1 kilojoule. To convert joule to kilojoule, you divide it by 1000. So that means that this 1000 joule is equal to 1000 divided by 1000, which is 1 kilojoule. So this 1000 joule is the same thing as 1 kilojoule if it is needed for us to convert it. Now this is the answer. Now example 2. For example 2, an object of mass 5 gram is located at a height of 2 meter, full stop. Calculate the energy of the object at the point or at that height, full stop. What type of energy does the object possess at the height or at the point? What type of energy does the object possess at the point? G is equal to 10 meter per second squared. Now solution. Now first of all, let's answer the type of energy. Say that the object is located at a height of 2 meters. Now there is no indication that the object is moving, and since the object that is not moving is at rest, that means that this object has potential energy. So the energy of the object is a potential energy. Now for the potential energy, we use the formula PE is equal to mgh to calculate it. Now let's come to the question and bring out the parameters given to us. An object of mass 5 gram. M is equal to 5 gram. It's located at a height of 2 meters. So we have H 2. Now we have our G 10. So we are going to have M is equal to 5, H is equal to 2, and G is equal to 10. Now potential energy PE is equal to mgh, which is equal to the potential energy PE is equal to m is 5, so we have mass 5 times by G is 10 times by height is 2. So we are going to have 50 times 2, which is PE is equal to 100 joules of energy. 100 joules. So this is the answer for this energy. The potential energy of the object at that height is 100 joules. Now let's look at the relationship that exists between work, power, and energy. In the previous lessons, we discussed work and power. We said that power is equal to work over time. The rate of doing work is power. Now, the unit of work is the same thing as the unit of energy. The unit of work is joules. That means that work and energy are talking about the same thing, because we said that the power is actually the rate of consuming energy, which is work. So when we are talking about work, we are also talking about energy. Now this means that we have that energy is equal to work. It's the same thing as work. When we are talking about energy, we are also talking about work. And work, the formula is from this one, W. If you want to make work the subject of the formula, we have that W is equal to PT. So we have that W is equal to PT. So this is the relationship that exists between the three. We have to introduce time into it, where T is the time. Work, energy is talking about work, or work is talking about energy, and work is the same thing as power times time. P is power and T is time. So this is the formula that connects work, energy, and power. Now what this simply means is that we can calculate energy by saying that energy is equal to PT. If we are given power and time and we are asked to calculate the energy of the object, we simply say that since work is equal to PT and work is also talking about energy, it also means that energy E is also PT. So we can say that energy is equal to PT, or we can say that work is equal to PT. If we are given power and we are given time and we are asked to calculate the energy of the objects, we use that energy E is equal to PT. And if we are asked to calculate the work of the object, we also use that work is equal to PT. So whichever one we want to calculate, we equate it to PT. That is the relationship. For instance, if you have this question, example 1, an example, if you have find the energy of a body, if its if it utilizes if it utilizes utilizes 20 watts if it utilizes 20 watts in 5 seconds. Now solution, let's bring out what is given to us, the parameters, the energy of a body if it utilizes 20 watts. Watts is the unit for power. That means that this 20 is talking about power. We have our power as 20 watts and we have time as 5 seconds. So we have P is equal to 20 watts and we have time is equal to 5 seconds. Now, since they ask us to calculate the energy, from the relationship between work, energy, and power, we can say that energy is equal to power times time, which is equal to 20 times 5, which is equal to 20 times 5, and that will give us 100 joules. So the value of energy from this is equal to 100 joules. Now this is how to calculate energy using the connection or the relationship between energy, work, and power. That is all we have in this lesson. So we have shown you how to calculate the potential energy, how to calculate kinetic energy, and how to calculate energy using the relationship that exists between work, energy, and power.